My project is on systems of linear equations, and my question is, an airplane flying into a headwind travels the 1,800-mile distance between two cities in 4 hours and 30 minutes. On the return flight, the same distance is traveled in 4 hours. Find the ground speed of the plane and the wind, assuming both are constant. The three ways to solve this are 1 by using substitution, 2 matrices, and 3 graphing it on the calculator. So the first method that I'll be using is substitution. And we're going to have two equations. One is going to represent the distance with headwind, and the other one will represent the distance with tailwind. So the first equation will look like 1,800 equals x minus y times 4.5. And I'll label the variables after I write the equations. And then the next equation will look like 1,800 times x plus y times 4, with x representing the plane ground speed and y representing the wind speed. When solving by substitution, we have to get one variable alone so we can plug in the value for that variable into the next equation. So in this case, we'll be using the first equation, and we'll have to distribute that equation. 4.5x minus 4.5y. Now we have to get x alone, so by doing that we have to add 4.5y to both sides. So plus 4.5y plus 4.5y, and then we get 1,800 plus 4.5y equals 4.5x. Then we divide both sides of the equation by 4.5 to get x alone. And then we get x equals 400 plus y. After solving this equation for x, it brought us to x equals 400 plus y. Now we could plug in 400 plus y into the next equation so we could solve for y. So 1,800 equals, and we're plugging this value into the second equation, 400 plus y times 4. So then we get 1,800 equals 400 plus 2y times 4, and when we distribute that we get 1,800 equals 1,600 plus 8y. Now we want to get the y alone, so we do that by subtracting 1,600 from both sides and then dividing by 8. So subtract from 1,600, and we get 200 equals 8y, and then we divide that by 8, and then y equals 25. So now we have x equals 400 plus y, and then y equals 25 as our two equations. And now we could plug in 25 into this equation and get what the value is for x. So x equals 400 plus 25, and that brings us to x equals 425. So our two values are x equals 425 and y equals 25. So the answer to this question is the ground speed for the plane is 425 miles per hour, while the wind speed was 25 miles per hour. So our second method of solving this problem is by using matrices. So here are two equations, the first one representing the plane flying with headwind and the second one representing the plane flying with tailwind. So in using matrices, you want to have the first equation on the top and the second equation on the bottom. And the way it's displayed is that the left side of the matrix contains the x coefficients, the middle contains the y coefficients, and the right contains the constants. So it would look like 4.5, negative 4.5, and then 1800, and then 4, 4, and then 1800. So the goal is to reorganize the original matrix, which is this one, to look something like this matrix where x is alone and y is alone and a and b are the solutions to the system. The first step is to get the x value in the first row to equal 1. So in order for us to do that, we have to multiply the top row by 1 over 4.5, which makes the matrix equal 1, negative 1, and 400, while the bottom row remains unchanged. The second step is to get the x value in the second row to equal 0. So in order for us to do that, we have to multiply the first row by negative 4 and add that to row 2. So we'll have negative 4 times row 1 plus row 2 to give us a new row 2, not row 1. After following that step, the second row should have 0 as its x value, 8 as its y value, and 200 as its constant. Now the next step is to multiply the second row by 1/8 so that the y value can be 1. So we'll multiply the second row by 1/8, which will not change the first row, but the second row will become 0, 1, and 25. The last step is to add the second row to the first row so we could have 0 as our y value in this first equation. When we do that, we get 1, 0, and 425 as our constant for the first equation, and 0, 1, and 25 as our constant for the second equation. And these two are our solutions. So when we rewrite these equations, we get x equals 425, since the y equals 0 in the first equation. And for the second equation, it'll be y equals 25, since the x equals 0 in the second equation. So the answer will again be the ground speed of the plane is 425 miles per hour and the wind speed is 25 miles per hour. The third method of solving this problem is by graphing. And all we have to do is solve both of these equations for y and then plug in those two equations into the calculator to solve for the intersection point. To solve the first equation for y, we have to first distribute the values, which goes back to the beginning where we have 4x minus 4.5y. Now, instead of wanting to get the x value alone, we want to get the y value alone. And by doing that, we have to subtract negative 4.5x from both sides. So we get 1800 minus 4.5x equals negative 4.5y. Now we divide both sides of the equation by negative 4.5. Then we get y equals negative 400 plus x. The next step is to solve the second equation for y. So we'll get 1800 equals 4x plus 4y. Then we subtract 4x. Divide both sides by 4. 450 minus x equals y. So the two equations that we will be plugging into our calculator will be y equals negative 400 plus x and y equals 450 minus x. So after you type in the two equations into the calculator, you press graph, and then you have two lines that are intersecting, and the solution to the problem is this intersection point. So you press second, trace, and then you press 5. Enter that, and there we have it. Intersection x equals 425 and y equals 25, and our x value is the plane's ground speed and the y value is the plane's wind speed.